For centuries, the ocean floor was for humanity what outer space remains today, a vast, dark, and inaccessible territory about which almost nothing was known. Even in the 20th century, when human beings reached the moon, more than 80% of the ocean floor remained unmapped in detail. That situation has changed dramatically in the last 2 decades, thanks to high-resolution sonar technologies, altimetry satellites, and fleets of autonomous underwater vehicles that have begun to reveal what lies in the depths with unprecedented precision. And what they have found has forced the rewriting of textbooks on geology, marine biology, and oceanography, structures of colossal dimensions that no one expected to find, formations that defy existing models, and underwater landscapes as complex and varied as any mountain range on the Earth's surface. Leave your like, subscribe, and share. Let's begin. The most ambitious ocean floor mapping project in history is Seabed 2030, a joint initiative of the Nippon Foundation of Japan and the GEBCO program, the General Bathymetric Chart of the Oceans, which aims to produce a complete and detailed map of the floor of all the world's oceans by the year 2030. When the project was launched in 2017, only 20% of the ocean floor had been mapped with high-resolution sonar. By 2023, that figure had risen to 25%, a significant advance but one that illustrates the magnitude of the challenge. 75% of the planet's ocean floor remains largely unknown territory. What the already completed maps have revealed is extraordinary. One of the most striking structures identified through sonar and satellite altimetry in recent years is the Clarion-Clipperton Fracture Zone in the northern Pacific between Hawaii and Mexico. This zone, which extends over more than 4 million square kilometers, is an abyssal plain at between 4,000 and 5,500 meters depth, covered with polymetallic nodules, concretions of manganese, copper, cobalt, nickel, and other metals that form slowly over millions of years. The high-resolution scans reveal that the nodules are not distributed randomly, but follow patterns that geologists link to bottom currents and to the tectonic structure of the ocean floor. But the oceanic structure that has most surprised the scientific community for its absolute dimensions is the Kerguelen Plateau in the southern Indian Ocean, south of Madagascar. It is a volcanic submarine plateau covering approximately 2.2 million square kilometers, an area comparable to the size of Greenland, and it rises from the abyssal depths to just 150 meters below the surface at its highest points. The seismic and sonar scans carried out by researchers from the Australian Antarctic Division and the University of Tasmania between 2016 and 2022 revealed that the plateau is structurally far more complex than previously thought. It is not a flat surface but a landscape of canyons, volcanic peaks, valleys, and stepped platforms extending to different depths. The geological history of the Kerguelen Plateau is fascinating and has implications that go far beyond marine geology. Analyses of rock cores extracted from the plateau's bedrock, carried out within the framework of the Ocean Drilling Program and the International Ocean Discovery Program, revealed that this structure formed between 110 and 100 million years ago, during the Cretaceous, as the result of a series of massive volcanic eruptions on the ocean floor that produced such a quantity of lava that they literally built a subcontinent underwater. Some models suggest that at its maximum extension, around 90 million years ago, parts of the plateau could have been above sea level, forming islands or even larger landmasses. Fossils of plants found in sediment cores from the plateau support this hypothesis. In the Atlantic, one of the largest and most recently characterized structures in detail is the Mid-Atlantic Chain, also known as the Mid-Atlantic Ridge, which runs through the ocean from north to south over 15,000 kilometers, from Iceland to the vicinity of Antarctica. Although the existence of this ridge was known since the 19th century, when submarine telegraph cable layers found that there was a central elevation in the Atlantic, its detailed structure was not accurately mapped until recent decades. The multi-beam sonar campaigns of the Ridge program and the famous project, the French-American Mid-Ocean Undersea Study, revealed that the ridge is not a simple crest but a system of rift valleys, active volcanoes, hydrothermal fields, and geological faults of extraordinary complexity. The hydrothermal fields of the Mid-Atlantic Ridge are perhaps one of the most important discoveries of 20th century oceanography. Since the first were found in 1977 on the East Pacific Rise, the exploration of these ecosystems has revolutionized biology. Hydrothermal vents, also known as black chimneys or black smokers, are openings in the ocean floor through which water at temperatures of up to 400 degrees Celsius emerges, laden with chemical compounds such as hydrogen sulfide, methane, and dissolved metals. Around those vents, in total darkness and under pressures that would crush any human being, exist communities of organisms that do not depend on photosynthesis but on chemosynthesis, bacteria that obtain energy from chemical compounds rather than sunlight, and which in turn sustain complete ecosystems with tube worms of up to 2 meters in length, crabs, blind shrimp, fish, and other organisms that exist nowhere else on the planet. In the year 2000, researchers from the Woods Hole Oceanographic Institution discovered in the Atlantic a hydrothermal field unlike any known until then, named the Lost City, located at about 750 meters depth on the mid-Atlantic ridge. Southwest of the Azores, the Lost City is not a field of black chimneys but a collection of calcium carbonate and serpentinite towers of up to 60 meters in height, formed by a different geochemical process that produces alkaline water at moderate temperatures, between 40 and 90 degrees Celsius. The Lost City is considered today one of the most relevant environments for research on the origin of life on Earth, because the chemical processes occurring in its fluids resemble those that scientists believe could have given rise to the first complex organic molecules more than 4 billion years ago. Leave your like, subscribe, and share. In the Pacific, the system of ocean trenches of the so-called Ring of Fire houses some of the deepest and least explored structures on the planet. The Mariana Trench, with its nearly 11 kilometers of depth at the point known as Challenger Deep, is the most famous, but it is far from the only one. The Tonga Trench in the southern Pacific reaches 10,882 meters depth, and the high-resolution scans carried out in 2023 by the 5 Deeps expedition research vessel revealed that its topography is extraordinarily complex, with steep walls, intermediate platforms, and a series of adjacent seamounts forming a tectonic system of impressive activity. Tonga is the zone where the Pacific Plate subducts beneath the Australian Plate at a rate of up to 24 centimeters per year, the fastest known subduction rate on the planet. One of the most unexpected structures detected through ocean floor scans in recent years is the so-called Great Unconformity, a geological surface detected on the floor of several oceans that represents a gap of hundreds of millions of years in the sedimentary record, a period in which erosion or lack of deposition produced an abrupt discontinuity between rocks of radically different ages. The seismic scans of the northern Pacific Ocean floor, carried out by researchers from the Scripps Institution of Oceanography at the University of California, San Diego, revealed in 2019 that this surface is far more extensive than had been estimated, and that its formation could be linked to the global glaciation known as Snowball Earth, which occurred approximately 700 million years ago. Satellite altimetry technology has been fundamental for mapping large-scale oceanic structures. Satellites such as the ERS-1 of the European Space Agency and the GeoSat of the United States Navy measure with centimeter precision the variations in the height of the ocean surface. Although these variations are very small, on the order of a few meters over distances of hundreds of kilometers, they faithfully reflect the topography of the ocean floor, because the gravity of submarine rock masses attracts water toward them, creating almost imperceptible but measurable elevations from space. Using this data, researchers from the Scripps Institution of Oceanography published in 2014 in the journal Science the highest resolution map of the global ocean floor produced until then, which revealed thousands of previously unknown submarine volcanoes, mountains, and trenches. Among the most surprising findings of recent years is the identification of brine lakes on the floor of the Gulf of Mexico and the Red Sea. These are accumulations of extremely salty water, denser than the surrounding seawater, which accumulate in depressions on the ocean floor and remain separated from the ocean, as if they were a lake. The ROV scans carried out by researchers from Temple University and NOAA in the Gulf of Mexico revealed that some of these brine lakes have temperatures above 40 degrees Celsius, and salt concentrations 4 or 5 times greater than normal seawater, making them inhospitable for most organisms. However, on their shores, communities of mussels, tube worms, and bacteria adapted to those extreme conditions were found. The discovery of seamounts is perhaps the most recurring finding in ocean mapping expeditions. It is estimated that there are more than 100,000 seamounts in the world's oceans, but the vast majority have not been mapped or explored. In 2023, an expedition from the Schmidt Ocean Institute using the research vessel Falkor and its ROV Sebastian carried out a 19-day campaign in the southern Pacific and discovered 4 previously unknown seamounts, the tallest of which rises 3,600 meters from the ocean floor, nearly the height of Mont Blanc, but without reaching the surface. On those mountains were found cold-water corals of up to 1 meter in height, glass sponges thought to have been growing for decades, and multiple species of crustaceans and echinoderms that biologists had never seen before. All of this, taken together, paints a picture that scientists describe with a mixture of wonder and urgency. The ocean floor is the largest ecosystem on the planet, covering more than 60% of the Earth's surface, and yet it remains the least known. While space telescopes map galaxies billions of light-years away, the seafloor covering our own planet remains, for the most part, unexplored. And every time a sonar or an ROV reveals a new area of that territory, structures, creatures, and processes appear that no model predicted and that force a rethinking of everything we thought we knew about how the planet we inhabit works. Leave your like, subscribe, and share. Until next time.